The lesson topic for this video is writing exponential functions. Now, based on what we've learned previously about exponential functions, I just want to remind you that writing y equals a times 1 plus r raised to the t power is the same as it's pretty much exactly the same, just with an x in our exponent. T sometimes we use just to represent time, but x is just fine as well, and we will be using this form today in our examples. Just so you also know, sometimes 1 plus r is represented by the letter b, so then both of these equations could be rewritten as these two. So y equals a times b raised to the t power, or y equals a times b to the x power. Remember that a is our starting amount or original amount, and x and y is any data point that would be true for that function. Okay, so for this example, it says, what if you started with $20 and your money grew to become $35.25 after 5 months? And we'll also say that the money is growing exponentially. All right, so we're going to use our function notation here. We want to say a couple different data points based on the information given here. Well, we know if we started with $20, that would mean f of 0, so 0 months from now, we have $20, so that's the initial amount. Then later, after 5 months, our x value is 5, we have $35.25. So to write this equation, I'm going to always start by writing our general form for an exponential function. So y equals a, the starting amount, plus the quantity 1 plus r raised to the x power. Now what we have to do here is we're trying to find the rate for this. I guess I didn't really ask that question, but that's what we want to do. We want to find the rate and write the equation for this situation. So to solve for the rate, to find the rate, we need to fill in every variable except for r. Okay, so every variable needs a value except for r so we can solve for it. Well, we know the a, the starting amount, is after no time has gone by, so 20. So we can put a 20 in for a. And we're not going to change 1 plus r because we're trying to find the rate. And then we do know another data point that we can put in for x and y because f of 5 equals 35.25. So we can put the 5 in for x and the 35.25 for y. Sorry, it's kind of squished in there. All right, now to solve this, we are going to use our solving steps as usual. So undoing PEMDAS, doing the inverse operations, we have to first divide by 20. And when we divide both sides by 20, we're going to end up with 1.763 equals 1 plus r, quantity to the 5th power. Now right here what we have to do is we have to take the 5th root of both sides of the equation, because if we have to undo the raising of this to the 5th power. So we undo it with the 5th root. Now on your calculator, you're going to see a button that looks like this. Depending on your type of calculator, you might find it under the math key if you've got a TI, or it's a shift and the up arrow key if you've got a Casio calculator. So you're looking for this. Now in order to use that with a 5th root, you'll have to first type in a 5. So you're going to type in a 5 and then that xth root, and that's going to help you take the 5th root of 1.763. So you should try that out. I'm going to show you the work here. So we're going to take the 5th root of this side and the 5th root of this side. The 5th root and the 5 cancel out. And when we take the 5th root on our calculator, we're going to get 1.12, and that equals 1 plus r. At this point to solve, we just need to subtract the 1 from both sides, and we're going to get 0.12 equals r. So we can say that the rate is 0.12, or you could also say that that's a 12% increase for our rate. And we know it's increasing because it went from $20 to $35 5 months later, and so that is absolutely growth. If you weren't able to locate the xth root on your calculator, just make sure you talk to me about that in class. Okay, so this is a similar example. I'd like you to pause the video and try this one on your own. Do note while you're doing this one, we start with 130 of something, who knows if it's dollars or items at a store, whatever, and we've decreased after 8 months or days or years or whatever to 16.06. So this is an exponential situation, and I want you to write the equation, find the rate, and tell if it's growth or decay. Then check to see how you did. Okay, so you should have ended up with a 23% decrease for this function. Negative 23% you could write it as, or 23% decrease. You should not write negative 23% decrease, because that'd be like a double negative kind of situation. So it's a decay situation, and the rate is negative 23%. Okay, and so for this last example, I just want to point out that if we have a graph of an exponential function, we can find the equation, the rate, and decide if it's growth or decay in the same way we just did with the previous two examples. We'll get our x-y coordinate pairs in function notation up here from the graph. Remember that our original or starting amount is always found where x is 0, so that's 0, 1. And then our second point can be shown sometimes, or you can find one that goes through an obvious x and y value. So 2, 7 here. 2, 7. And then once again, we're just going to write this in our similar fashion that we did on the previous screen, where we're putting those values in for x and y and a. So 7 equals 1. 1 plus r raised to the second. Dividing both sides by 1 isn't going to change anything here. If you want to rewrite that, you can. But we need to square root this time, just a regular old square root. And we're going to get 2.646 equals 1 plus r. And we're going to subtract 1 from both sides. We're going to get 1.646 equals r. Now think about what that rate means. If we move that decimal 2 places to the right, we're going to get 164.6% increase. Now, what does that mean exactly if you have a 164.6% increase? Well, it means that it's growing more than it's more than doubling, because a 100% increase would mean it doubles. So a 164% increase means it's more than doubling, which makes sense because after no time we have 1, and then after 2, again, hours, months, weeks, years, whatever it is, we have 7. So it's definitely more than doubling. So a 164.6% increase means that this is a growth situation. We can also tell that by just looking at the growing from left to right on the graph.